Technology isn't just a part of our everyday lives anymore. It's become a frontier for global powers, with India right in the mix. So why not join the conversation? Take the Technopolitics survey created by researchers at the Takshashila Institution. It's just 10 simple questions, but your answers could help shape India's strategy in navigating the fast changing world of high tech geopolitics. Your voice matters, so let's make it heard.
Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello and welcome to this episode of the All Things Policy podcast. I am your host for today, Arindam Goswami. I work at the Takshashila Institution in their high-tech geopolitics program. And the topic that we are going to discuss today is a very relevant and important topic. Recently, Delhi has been in news because of the severe air pollution problem that it is grappling with. There are many causes for this, of course, crop residue burning being one of them that is being talked about a lot. In general, Indian cities face the problem of air pollution, and there are quite a few public policy interventions that get discussed and implemented, sometimes without proper reasoning and data to back them. And every such policy intervention has its costs and unintended consequences. They may not even solve the problem that they are targeting. It therefore becomes very imperative to analyze such actions logically and look at data before taking those decisions. Policymakers need such tools and frameworks that can help them decide what to choose to implement from a bouquet of actions that may be available or that may be proposed at various times. Actions which can be expected to have the optimum impact. And to discuss this today, I have with me Srinivasan Iyengar. Srinivasan Iyengar is a senior program manager at a major multinational company. He completed his PhD in computer science from University of Massachusetts Amherst. His research focused on distributed systems, cyber physical systems, cloud and edge computing, and smart cities and energy. He has co-authored a paper on identifying global air pollution sources, where they have talked about air pollution in general and PM 2.5 pollutants in particular, and built a model that captures the interplay of various factors, geographical, chemical, meteorological, that contribute to the concentration of PM 2.5 pollutants and identifies the polluting sources. They've also suggested that policymakers should probably be using such models and such data to help them take their decisions more optimally. So yeah, welcome Srinivasan Iyengar. It's great to have you back on this podcast.
Hey, thanks for hosting me once again. Very happy to be here.
So, since we are talking about air pollution, the air pollution problem that Delhi is grappling with, and in general, that is a problem with Indian cities, could you probably give a short overview of what are the various components of this air pollution problem, and in specific, what are PM 2.5 pollutants and why are they so important?
Sure, would be happy to, Arindam. So, essentially, air pollution, of course, is a major health hazard. I think the audience that is listening to this podcast obviously knows that very well. So, there are several gases or particulate matter that are classified as pollutants. For example, gases such as ozone and nitrous oxide, sulfur dioxide. All these gases are harmful to humans and are classified as pollutants. But what the evidence is, it's quite clear that PM 2.5. So PM 2.5 is nothing but particulate matter that is less than the size of 2.5 microns in diameter. And what the research clearly shows is that that causes 80% of deaths. So it's a significant air pollutant, and our focus is primarily on PM 2.5 because that is the major source of all the cardiovascular diseases, cerebrovascular diseases that people see or get because of pollutants.
So there seems to be a lot of confusion in the way pollution values are reported. I have seen AQI, PM 2.5, PM 10, etc. Right. Also, we know that some specific pollutants are measured in parts per billion. So, what is the right unit to focus on, and what should be the right way to measure these things?
Right. So typically, what you see is that when we talk about gaseous pollutants like ozone, sulfur dioxide, etc., they are measured in parts per million, parts per billion kind of units. Particulate matter, essentially, the unit that is being used is micrograms per meter cube. So essentially, it's a density measure, right? What mass of PM 2.5 you have per unit of volume, right? And AQI just happens to be like a weighted measure of all the different pollutants. Honestly, I feel that AQI hides a lot of nuance. For that matter, any metric which tries to do this kind of like weighted average kind of an approach, right? It typically hides a lot of nuances that are inside, like from considering a set of pollutants. So I would rather suggest we should just focus on PM 2.5 units, which are measured in micrograms per meter cube. By no means I'm suggesting that this is a perfect measure, right? So if you notice, as I mentioned earlier, PM 2.5 particles can cause severe health issues. And what is being shown is that actually it's the exposed surface area of the particulate matter which has a bearing on the health outcomes, not necessarily the density. Obviously, as we know from simple physics, right? A singular big object, think of a cube which is 1 meter by 1 meter by 1 meter size, right? It will of course have 1 cubic meter of volume, right? If you divide that into smaller cubes, we still have the same volume, but the surface area is increasing significantly, right? So by no means PM 2.5 is a perfect unit, but that is easier to measure because of the type of sensor and measurement units that we use. So it's I would not say it's a bad proxy at all, but AQI sometimes muddles the picture because it's a weighted average, and not all components of that weighted average cause equal harm to humans, right? So the approach that we have taken in our paper is to just focus on the PM 2.5 because that is what is causing the maximum health issues that we see in people.
Right, right. That's a great primer, which includes physics also. So that was great. Like PM 2.5, as I understand, is a combination of seven constituents. If I have gotten it correct after reading a paper, also sulfates, nitrates, organic carbon (OC), secondary organic aerosols, black carbon, dust, and sea salt. Right. So, if you could maybe just talk about these pollutants, and as you have also discussed in your paper, what are the direct predictors, and what are some proxies that can be used to work them out?
Right. So essentially, think of this as with any scientific categorization, right, or nomenclature that we use, right? It simplifies the stuff. So again, it's just that scientists have picked these seven categories. Of course, I can choose any more number of categories because there are like millions of different types of organic gases and volatile organic compounds that are exposed in the atmosphere, right? So for the sake of simplicity, let me just list out the seven. So essentially, like one of the major sources of pollution that we see not just in India but around the world is called nitrates. As the name suggests, it contains nitrogen. The second type of PM 2.5 constituent is called sulfates. Again, this contains sulfur. And of course, there are several other components such as organic carbon and also what is called as secondary organic aerosols. There are also a couple of benign PM 2.5, relatively benign 2.5 constituents called dust, which may probably give you a runny nose, but will probably have less of an health issues compared to the earlier ones that I mentioned. And of course, sea salt, right? As we have monsoonal winds in India, these strong winds actually carry a lot of sea salt also in them, right? So that is also part of PM 2.5, but obviously sea salt is not as harmful as some of the other compounds that I mentioned. And the seventh one happens to be black carbon. So even though the proportion of black carbon in the PM 2.5 constituent is very low, but in some ways, that is one of the worst kinds of particulate matter that you can breathe in, right? So even though it is in low dosage, it is shown to be have very bad health outcomes on people. So these are the seven: nitrates, sulfates, organic carbon, secondary organic aerosols, dust, sea salt, and black carbon.
Right. Could you also talk about what are the sources of these pollutants? What are their direct predictors? What are their proxies? Which ones of them are like correlated? So if there's a presence of one, you could deduce the presence of another. So if you could like just give a brief primer on that part also.
Sure. So actually, this travels into territory of atmospheric chemistry, and fortunately for this paper, we had atmospheric chemist as one of the co-authors. He was a PhD student at IIT Kharagpur, and currently is pursuing his postdoctoral studies at Karlsruhe. And that's Pankaj Kumar. Just wanted to acknowledge his effort. And another student who worked with me and led the whole paper was a currently is also a PhD student pursuing his PhD at Cornell. His name is Dhruv Agarwal. So just to talk about these specific PM 2.5 components, right? So nitrates and sulfates are not directly produced by any source. They are actually formed over time when nitrates and sulfur dioxide gas reacts with oxygen and ozone, right? And of course, actual rocket science is not rocket science. The real rocket science is atmospheric chemistry. There are literally like thousands of chemical reactions happening in our atmosphere. So don't want to trivialize the complexity of the type of interactions, chemical interactions that happen in an atmosphere. But roughly speaking, sulfur dioxide can react with different components in the air to form sulfates. As I mentioned, NO2 and NO can react with several components in the air to form nitrates. Dust and sea salt are directly produced from the sources. Like dust is wherever there is human activity, there would be dust particles. It can be anything from dead skin of people to different components withering out and that causing some residue. Sea salt, of course, come from the ocean. Organic carbon and black carbon are directly produced. So whenever there is biomass burning, like we see in our farms, right, that can produce organic carbon and black carbon. The secondary organic aerosols, also as the name suggests, are formed when organic carbon, like PMO2, let's call it, like organic carbon PM reacts with other gases. One of the more reactive gases is ammonia. So when ammonia or similar such gases react with organic carbon, they might form secondary organic compounds, and they are called secondary organic aerosols, right? So there are different ways in which they are produced. Like as I mentioned, NOx, as they call it, can produce nitrates. Sulfur dioxide produces sulfates. Organic carbon and black carbon are directly produced by biomass burning or even from incomplete combustion of diesel in gensets and in trucks and other engines. Of course, sea salt and dust I've already mentioned, and essentially secondary organic aerosols are formed by interaction between organic carbon and some other reactive gases. Example being ammonia.
Right, right, and you mentioned in your paper that there are some of these pollutants which are highly correlated. So once
Right.
you have the presence of one of these, you can sort of deduce the presence of the other. So could you maybe explain that a bit?
Correct. So, for example, as I mentioned, SO2, right, sulfur dioxide. So, primarily, sulfur dioxide is produced by burning coal. So, naturally, this will happen in thermal power plants and also some steel plants which use coal. So, these are because also, unfortunately, in India, the coal that we use, which is form called peat, it has a very high sulfur content. So, that also leads to a lot of sulfur dioxide emissions. If you just look at, there are different websites. One of the popular ones is called Null School. So you can actually look at sulfur dioxide being produced in different parts of the world. And what you strikingly, it's quite striking, is the fact that wherever there is a thermal power plant, and especially if you are using an old thermal power plant with not so good quality coal, you will notice that there is a big plume of sulfur dioxide coming from there. Obviously, sulfur dioxide gas doesn't remain in atmosphere for a long time. It reacts to form sulfates. And typically, these PM 2.5, they are quite inert in nature. So they can persist in atmosphere for long time. They can move along with the wind. So there is a big possibility that the source of pollution and the people who suffer may be even hundreds or thousands of kilometers away. right? In fact, not all PM 2.5 is bad, right? So, in fact, as the winds take sand from Sahara, those sands are deposited in Amazon rainforest, and in fact, that replenishes the rainforest. Right, the top layer is continuously replenished, so it's quite awesome to see that in our world we have dust which is carried across the Atlantic Ocean, which is actually ensuring that Amazon rainforest survives. Right. So, just wanted to say that not all PM 2.5 is bad, and just by looking at the PM 2.5 number in isolation doesn't give you a complete picture. Right. So, something like sea salt will not be as harmful for you as compared to, say, some of the other ones like organic compounds, things like that when you inhale them.
Right, right. So just like human beings contain multitudes, particulate matter also probably contain multitudes. So yeah, that was
Right.
just a joke
Right.
that I wanted to crack. And I like the phrase that you said. Rocket science is not rocket science. Rocket science is probably atmospheric science. So this is an interesting phrase that you made, and that sort of. Also explains why we are going into these details, and thanks for explaining this to for our listeners in a very easy to understand manner, because unless we know these details, it's difficult to look at the public policy angle, public policy interventions, and the public policy actions that we need to take to tackle this problem, which we'll come to later on in our podcast. But it helps to have this background. So, continuing with this background a little bit more, I would like you to talk briefly about what are the various factors that affect air quality in a city. You have listed down three in your paper, but if there are any others that also you can mention. But you mentioned three, that is geography, chemistry, and meteorology. And I understand that India has a unique geographical profile. There's Himalayas at the top. We are surrounded by ocean or sea and ocean on three sides. We also have the Tibetan plateau, which sort of protects us from some geographical impact. But then this unique geographical location and profile of India also affects how air quality is, in different parts of the country. So, if you could just talk briefly about these three factors that you have mentioned in the paper, and any other factors that you think are relevant here.
Yeah, sure. So basically, we have covered the chemistry aspect more or less, right? So just to stress on the point that PM 2.5 is not, it's more like an umbrella term. So there are several constituents to it, and each constituent has a unique chemistry about it, right? That is about the chemistry aspect. So coming to the geography aspect, right? So if you look at the Indian subcontinent, right? Over a million years ago is when our subcontinent actually collided with the Eurasian plate, and which formed the Himalayas, right? Which is one of the youngest mountain ranges in the world, right? So and the crashes was quite violent, and there are mountains. In fact, all the tallest mountains, all the 14 tallest mountains in the world, are found in this particular region, right? And also, if you look at to the northeast of India, right, we have the Tibetan plateau, which is multiple thousands of square kilometers of a very tall plateau, roughly around 4 kilometers from above sea level, right? So even though like China is one of the biggest polluters in the world, most of those pollution centers are in the far east and on the other side of Asia, and these pollution sources are very far off from us, right? And of course, even if some gases try to come towards the west, towards India, the Tibetan plateau will not allow these gases to come in a big way, right? And if they allow, there is always Himalayas, which is going to protect us, right? So most of the pollution that we see in India is primarily because of our own doing, right? If you look around us, we are surrounded by mostly agro economies, not necessarily powerhouse industrial economies that are producing a lot of pollution or manufacturing, right? So, just wanted to highlight that we are surrounded by, on at least we are a peninsular country, and the neighboring countries, the land borders that we have, are not necessarily industrial powerhouses, right? So most of the pollution is because of our own doing, right? Apart from the Himalayas, which block the pollution from the coming from the north, what it also does is that just below the foothills of Himalayas, you have the Great Indian Plains, right? And what happens is that in this region, it's far off from the ocean, so there is a significant temperature difference during summer and winter season. As you know, let's take example of Delhi, right? It's quite common to have temperatures below 5 degrees Celsius during winters, and in summers it can get really warm, right? And especially during winters, right, as there is no water mass nearby. For example, Mumbai, cities like Mumbai, Chennai, and Kolkata, they have a ocean right next to them, right, which is a very big heat sink, and it can release heat very slowly, right, whereas land release heat very quickly, right. So what happens then is that many times, because of this quick release of heat during the winter season, there is something called as temperature inversion, right. So what happens is that the atmosphere very close to the ground becomes very cool, and if you go up some say 300 400 meters above that, the air is quite warm there, right. So essentially the convection current that typically happens, right. So if you heat up water in a big tub, you will notice that even if the burner is at the bottom, you will see that the bubbles are coming up, and slowly the convection currents will make sure that even the top of that water at the top is also equally hot, right. So because of this temperature inversion, there is a lid placed on whenever there is a temperature inversion. So the convection currents that will take the pollutants at much higher elevations stops, right. So that's why if you notice in winter season, many times you will notice that there is a lot of problem with our flights landing in Delhi because of excessive smog. And if you just go about half a kilometer away from the ground level, right, you'll see that the air is pretty clear, right. That is because of temperature inversion. All the pollutants are restricted to this 200, 300, or 400 meter thick air, right. And generally this layer where pollutants can move, the convection currents can take them, or the molecules can disperse, is high as 5 to 10 meters, right. So this layer is in, technically it's called what is called as a planetary boundary layer, right. So sorry to get very technical, but this point is very important, that even though Delhi is probably as a city is there are vehicular traffic almost every day, the pollution is happening throughout the year. You will notice that during winter season, especially like late December and early January, and we are going to enter that phase, and it will be quite evident, and I'll be shocked to know if this doesn't happen, that there'll be excessive smog. And that smog is there for only a few hundred meters from the ground, and above that it's totally clear. So imagine that all the pollution that could spread almost 5 to 10 kilometers above the surface of the earth is now compressed to a very small volume of say 300 meters height, right. So literally all the pollution is compressed at a very small area, and that's why you have excessive smog, and the PM2 levels are quite excessive, right. So that's how geography plays a picture, not just from the perspective of our subcontinent, and also the unfortunate reality of temperature inversion that happens, which causes all the particulate matter to not escape beyond a few meters, right. So that's how geography impacts the actual pollution levels, right. And of course all these temperature inversion happens because of certain meteorological conditions, right. For example, if the wind speed is very low, the heat transfer from the earth is very fast. So there are specific conditions in when there is this inversion that happens, which leads to like all the pollution being trapped in such a small area, right. So primarily speaking, these are the three factors that broadly explain why pollution is there in different parts of the country. So of course there is the chemistry aspect of it, right, how the particulate matters are formed or directly emitted, how the chemical reactions happen to form different kinds of PM2.5. Second is, of course, the geography, how large mountains can stop air from going from one place to the other, but also like the industrial, the countries that are nearby, right? They are not necessarily, causing that much pollution, right? And of course, the climate also plays an important role in the PM2.5 levels to rise during certain times of the year.
Fantastic, primer of the factors that affect air quality in the city. It was especially interesting to note the concepts of temperature inversion and planetary boundary layer height concept, right? Because what you're essentially saying is that because of this temperature inversion and because of the PBLH being high during, say, the summer months, but being low in the winter months, although the problem of air pollution persists across the year, and especially the problem of crop residue burning happens twice a year, right? It happens once probably in the Kharif sowing season, probably somewhere around March, April, I guess.
Yeah, harvest season.
harvest season, and then there's the one that's happening currently that's in news, right? But the one
Correct,
that's
correct.
happening now or in the winter seasons is noticed more or causes more problems because the pollutants are restricted to a smaller layer, and that's why probably the density is higher in that particular layer, and that causes more problems, right?
Right,
Is that
right.
the right understanding?
Yeah, so there is clear evidence, right? So in our paper, we have used satellite imagery to identify thermal or biomass burning events, right? So there is this awesome data set called VIIRS from NASA. And we use that to identify when there is any thermal activity or heating activity or burning activity, right? So if you notice in India, the crops are burned twice, right? One is during the May season, and the second one is during the October-November season, right? And as you rightly pointed out, the amount of crop burning or the fires that you notice from satellite imagery, it's almost same during both these periods. It just so that the geography and the meteorology is such during the October-November month that because of the boundary layer being low, that leads to this pollution levels increasing quite significantly, right? Because the pollution that could disperse over a atmospheric height of 5 to 10 meters is now restricted to just half a kilometer, right? So imagine compressing all that pollution to just 5% of the original volume, right? So that's why you see higher PM 2.5 levels, right? Not to mention, I mean, this doesn't mean that in May there is no increase in PM 2.5 level. There is definitely a noticeable increase during that time, but the amount of increase that you see in the October November month is much higher.
Right. So basically, what you're saying is Delhiites have gotten used to a higher PM 2.5 level to such an extent that they don't notice it in summer months, but they notice it in the winter months, which is sort of sad. But yeah, that's
Yeah,
something that's
just
happened.
to give some context, right? So, WHO, the safe prescribed level for PM 2.5 at an average level is around 10 micrograms per meter cube. I think Delhi's average is around 80, right? So, 8 times the level or even more than that, right? And it's not just a Delhi problem. So, it just so happens that it's a capital and it has a very high population. But if you look at all the top cities with the highest pollution levels, right? So, most of that are in the Indo-Gangetic belt, or some of them are actually in the Indus belt also. So, just a couple of weeks ago, I saw that Lahore was the most polluted city in the world, briefly taking the crown away from Delhi. So there is a unfortunate rivalry going around in who can become worse at like facing pollution, right? And so the definitely this PM 2.5 values are quite elevated, and in fact, there is hardly any period in Delhi which would classify as a safe period according to WHO standards.
Right, right. It's sad that we have gotten used to this polluted air to such an extent that we have taken it for granted as such. And I hope this podcast episode of ours, because of the background and the science behind it that we are putting forth, people, our listeners, would be better educated and probably would raise their voices in whatever way they can to get this problem
Right.
solved.
So just to stress one more point, right? So I understand that there is a lot of what are in a way euphemistically called as climate deniers, right? So climate change, there is actually some debate about it, about some of the claims that is being made. The same scientific opposition is not there in pollution, right? So if you dig up mummies during the Egyptian period, right? So there were some people who are just restricted to mining coal, right? And even now, if you notice their remains, you will notice that there is excessive carbon inside their body, and I mean, it's not something which is like concocted by some evil people or evil scientists, right? So the evidence out here is like beyond question, right? Compared to say climate change, where there is some debate about what is the human impact of climate change, right? Whereas it's undeniable that pollution currently what we are facing is primarily because of human sources and human activity. Now, of course, there are other factors which can be natural, right? As I mentioned, like the dust storms coming from deserts or even volcanic eruptions, right? And in fact, our work takes some of the algorithms which are used to track the plume of volcanic eruptions, how it travels, right? So we have got inspired by some of the earlier work, and we have built on top of those giants who have come up with those algorithms, and we can talk more about that in the future.
Great, great, fascinating. It's good to know that people are at least agreed on this problem, right? If unlike climate change deniers, yeah. So yeah, coming back to the question of the seasonal variations also that you have mentioned in your paper, right? So what are like some of these seasonal variations that we need to account for? You mentioned the southwest monsoon winds, and so if you could maybe elaborate a bit on that.
Right. So, as we mentioned, right, so crop burning is a human activity that happens during October, November season and also in May. That's a seasonal event. Of course, it's a human event, but it happens with the regularity, right, which matches the seasons, right? My bet is that in December or early January, right, and I hate to bet it on something which is quite gross like air pollution. My bet is that the pollution levels may be, in fact, higher than what we see right now, right? And the sources for that pollution are not necessarily the crop burning events that have happened, right? Because those have already happened in October, November. Most of the particulate matter would have dispersed around the atmosphere or maybe settled to the ground, right? So, as I mentioned earlier, in winter season, that is in late December and early January, the pollution increase that you see is because of completely local factors, right? Mostly it is Delhi's pollution or pollution from nearby areas that is causing the pollution, and because of the planetary boundary layer being pushed down, right, all the pollution which could have dispersed around a larger volume of air is compressed to a very small volume of air, like 5 to 10% of that volume that is normally there. That's why there is a higher increase, right? So that is definitely something seasonal. Also, there are other activities, right? So in peak summer and peak winter is where our energy demands grow up. So that's where the thermal power plants are running in full steam in our country. And in fact, in our paper, we have shown that, especially in winter season, some power plants, which may be almost 700 to 900 meters away, they have a high predictive power for measuring what the PM 2.5 levels in Delhi would be, right? Not to mention that there are vehicular traffic because of incomplete combustion and also like just general consumption of diesel, which releases a lot of pollutants. And also there is also broken window economics happening out here, right? So our grid is notoriously fragile, which leads to people having their own diesel gensets. And whenever there is excessive demand, right, I mean, this is a repeating pattern, right? So in India, we always make the same mistake 100 times over before fixing it, right? So literally each big house in Delhi is sitting on a sump of diesel, right? So it's built up in the plants, right? They have a diesel storage and they have a diesel genset. So the worst time when there is a blackout during these peak energy demand periods, that's when you use your diesel gensets, which also contribute in a big way to pollution, right? So it's very unfortunate that there could be some simple fixes to this problem. By making grid more resilience, you are not only going to provide better quality, I mean, living conditions for our citizens. In fact, it will reduce the cost that is borne by citizens by investing in diesel gensets. And also, it is increasing the pollution levels, right? So these diesel gensets are not extremely efficient, and the pollution that they release is in urban areas, right? So there are like multitude of reasons which where we seem to, as a country, seem to be complicating the problem, right?
Right, right, right. So basically, what you're saying is this is a very complex system, right? There are multiple factors that affect air quality in a particular location. In this case, in the case of a paper, Delhi. You also talked about like sources or locations that are hundreds of kilometers away from the sink location. Sink location being the
Delhi in
in
this case, yeah,
Delhi in this case, where the pollution sort of congregates, right? And yet
right.
these locations, which are like hundreds of kilometers away, have considerable impact on the air pollution at the sink. So maybe if you could elaborate on this, like sometimes these locations
Yeah.
are places which you might not even imagine contributing to the air pollution at the sink, right? So this makes the problem even more complex. You can't really wish away such complexities, but probably models such as yours will enable policymakers to take into account these complexities also, right? So in that sense, what your paper does or emphasizes on is why is it important to do source identification and analysis, right? So if you could probably elaborate on this part, right?
Right. Right. So this will take a couple of minutes. I'll try to
Yeah.
summarize the technical aspects of the paper in a simple language. Right. So typically, if you look at the sources of pollution, right. So there are in India at least we have tried to categorize into four main categories. One is biomass burning, which often gets a lot of blame, but it's not necessarily the number one factor for the pollution being high throughout the year in many parts of North India, right? The second is, as I mentioned earlier, the thermal power plants that we have, especially those that use low-grade coal, which is present in our country. There are also industries and steel mills that use coal directly, and also human activity, right? Let's not forget that each population center, so India has more than 50 cities with 1 million population, right? Whenever there is pollution aggregation, whenever there are people aggregation, there is use of vehicles, there is use of diesel gensets, is several human activities around it, which also causes pollution, right? So what we have done is we have used a statistical approach of sampling to look at the whole of the country, and just by sampling around 68 locations in the map, right, in the Indian subcontinent. So some of these places are also in Pakistan and in neighboring Bangladesh, right? With just this smattering of 68 locations, what we have tried to do is look at how the air molecules might move from these source to sink locations, right? So the source locations are what we feel from the fires data from NASA. We notice that which areas have a lot of crop burning. From power plants data that is available from National Power Portal, we have looked at the locations of the power plant. Similarly, locations of steel plants are easily known. Then we looked at the population density maps, and then tried to we identified these 68 places. That's step one. In step two, what we do is we run actually a 70-year-old algorithm called high split, right? So high split is essentially a simulation run, which in mathematical terms it's called running a Lagrangian, right? So essentially what it does is that looks at the wind vector and does simulations of around, we can do simulations for around thousands of particles, right, and see how they will move from now to say 3 days from now, in 4 days in the future, or 5 days in the future, right? You can actually track those molecules, not just in terms of the latitude and longitudinal grid, right? Some molecules may rise up in the air, some may fall down to the earth, right? So it's a fairly sophisticated algorithm, but not a very new algorithm at all. It has been around for 70 years, and with just minor revisions over the past 70 years, it's a very successful model that we have used. Apart from that, we have used a game-changing data set, again, thankfully released by NASA, called GEOSCF. Right. So essentially, this data set, I think, was released around 2018, 2019. And what is cool about this data set is that it has an exhaustive list of around 50 odd chemicals or gases or particulate matter, right? It gives you those values at not just at a grid size of the world of around 0.25 degree latitude to 0.25 degree longitude. So at that spatial granularity on the ground, and at different height levels also, right? For different, as you know, as we go away from the surface of the earth, the pressure values reduce, right? Atmospheric pressure reduces. So essentially, think of the atmosphere as a big 3D structure, and we are dividing that atmosphere into latitude, longitude bins of 0.25 degrees each. And also, we are stratifying this atmosphere by height based on different pressure thresholds, right? So essentially, you can track the molecules from the source to the sink, and of course have to run thousands and thousands of simulation to identify which particles are coming from where, right? And the cool thing about what we feel about our work is that we get these values at a granularity of an R. So, for example, when we predict that PM 2.5 values will be around X in Delhi today, we are not just saying predicting that value, we are saying that what is causing those values and what constituents of PM 2.5 are causing those values, right? And that gives us the power to actually, to put it bluntly, assign blame, right? So, if we know that there is particles coming from a power plant around 1,000 kilometers away, right? We can actually put some blame. Now, of course, not all the blame. There is pollution is never monocausal. There are multiple factors out there, but at least in a statistical way, assign blame to different sources that are present in the country, right?
Right, right, right. So now that you've mentioned that each of these pollutants may have different characteristics, right? Some might travel for long distances, some require a long time to change into pollutants. So how do you account for all these complexities, right? So I mean, there are different sources. To do your calculations, you had used something called forward and backward linkages, right? Something of that sort, right? So
Correct,
could you
correct.
maybe talk through that and then
Yeah.
talk about
Right. So
the.
as I mentioned earlier, right. So atmospheric chemistry is the real rocket science, right? There are literally thousands of chemical reactions happening in the atmosphere, right? And we can't account for all of them, right? So let me give an analogy of nuclear physics, right? So I cannot look at any atom of uranium and say that it is going to fission on its own in another second or another 10 seconds, right? We cannot make that. We don't have an accurate way of just looking at an atom and saying that this is going to decompose into or fission into other elements, right? But what we can say is that if you have a lump of uranium, you can give a half life to it. Very precisely, you can say that after x amount of years, only half of the uranium will be present, right? So again, this may be a crude analogy, but we use a similar approach, right? We are not claiming that we know exactly how and when the chemical reactions will happen, right? But we know that over several days, this SO2 and NO2 will react with certain gases to form sulfates and nitrates, which are PM 2.5, two of the major 2.5 constituents. And in general, PM 2.5 constituents are chemically much less inert compared to many of the gases, right? So, for example, ozone, all these gases are highly reactive, right? They don't survive in the atmosphere for a long period. Unfortunately, PM 2.5 will not only survive for many days because of the wind, they can move around large distances, right? Sometimes even hundreds and even 1,000-kilometer journeys can be done, right? As I mentioned, right? So the dust from or the sand from Sahara can actually cross the Atlantic and fall on Amazon rainforest, right? Over a matter of months, right? So these things happen, right? So these are some of the factors, right? So the forward and the backward run is kind of a technical thing. I would like to just briefly describe by saying that running computational simulations is very running simulations is very intensive. So we did a simple hack where we, rather than going backwards from Delhi to observe where these particles have come from, we did both a backward run and forward run of molecules, right? Where we not only track what molecules are coming towards Delhi, we also track where these different 68 source sites that I mentioned that are selected in the Indian subcontinent, how they can track over time, right? And if these two particles, the backward particle from Delhi and the forward particle from these locations, if they meet at a cuboid space, right? When I say cuboid, it is the 0.25 degree latitude and longitude grid, and also the pressure gradient at the elevation, right? Whenever they meet, we know that these particles have traveled each other, right? So this is just a hack to reduce the number of simulations. But essentially, what we have seen is that we were surprised to know that our approach actually leads to predicting the pollution components to an accuracy of around, say, 10 to 20% of error, right? Which is quite significant. We were actually presently surprised to note that, right?
Right. And do your results compare with the other official data that the governments put out, right? Like say CPCB data and others, right? So and given that sort of error margin, how is the model still relevant? Right? We were talking about
Correct,
that.
correct.
If you could elaborate on
Yeah.
that also.
Yeah, so actually we anticipated this question, and in fact, for complete transparency, right? So we actually ran the model to fit the pollution level to the actual CPCB pollution monitors on the ground, and the error in that case was very high, right? Almost 50%. But please be aware that the purpose of these two works is very different, right? You install on-ground sensors to know several things, right? You can actually notice what are the hyper local factors of pollution that is causing the pollution, right? So for example, if you are very close to the road, you will notice one level of pollution. If you just go 50 meters away from the road, right, and imagine there are a lot of trees in between, right? So the pollution level that you notice is very different, right? So pollution inherently has a lot of hyper local components to it. The purpose of our study was to not to go at a hyperlocal level. In fact, we had done some earlier work on pollution on hyperlocal level monitoring, which were published in other venues. The purpose of this work was to look at global factors, right? On average, what is the impact of, say, a power plant which is hundreds of kilometers away? What amount, how much predictable the pollution of Delhi is, especially the sulfate component, for example, from the power plant running some 60, some 700, 800 kilometers away, right? So, and also, we also look at local factors. I'm not saying that local factors are totally ignored. In fact, pollution in Delhi, or SO2 or NO2 and all these gases that are produced locally, those molecules may remain there, right? So the particulate matter doesn't always go around hundreds of kilometers, right? Some particles may actually remain inside Delhi also. So we do account for those parameters as well, but it would be wrong to compare the study about global movement of particles with what you see on ground, right? On ground values are affected by several factors, right? As I mentioned, a lot of hyperlocal factors. Whereas our approach was not just to measure the pollution values, in fact, to assign blame, as I said, or at least make an educated guess for why the pollution is higher at some times of the year and why it is happening. And most importantly, it's available at a granularity of an hour, right? Which is something unique, which no other study has done.
Right, right. And given all of this analysis that you have done, how do you think such modeling is important for a policymaker, right? How should policymakers, use these tools or use these models that you have built or written about to better make decisions regarding air pollution, right? So, I mean, for example, we every time Delhi faces this problem, we have myriad policy interventions touted and implemented, right? Like say the odd even rule or air purifiers in outdoor locations, and some of these seriously seem very nonsensical sometimes. Spraying water on the ground, on the roads, etc. Right? So, what is the importance of models like yours to better inform policymakers so that the decisions they take account for their unintended consequences and actually make sure that they tackle the source of the pollution, right, and actually have an impact on the ground?
Right. So that is what is the most frustrating thing about the discourse in our country, right? So there's literally no data based discussion that is happening, right? I'm not saying that none that is happening, but honestly, all these are knee jerk reactions, is what I can see. Again, this is my opinion, right? And essentially, as you pointed out, right, just spraying water on the ground, right? How many such tankers will you use? Will you douse the whole of the city with those tankers? Right, and also there are these like smog towers, right, which claim to clean up the air, right? I mean, just to give a rough calculation, right? So these smog towers, I just read about them that they can clear up an area of say 50 meters from them, right? Let's be a bit generous, right? Let's say that they are effective up to 100-meter radius, right? And they claim that they can reduce the pollution level by 70-80%. Just note that the PM 2.0 levels are so high in Delhi, in especially in the winter months, that even 70-80% reduction will mean that the PM 2.5 level is 10 times that of the WHO levels, right? Okay, let's again keep that aside, right? So imagine you have these smog towers which can clean up the air. Each one costs around 20 crore rupees, is what one of the newspaper reports claimed, right? Um Delhi has an area of 1500 square kilometers, right? So it will literally take like some obscene number of such monitors, right? And if we do the math, that overall, if we want to blanket whole of Delhi with these smog monitors, of course, there's no space in Delhi to accommodate these towers, but just be that as it may, right? If you do the actual math in terms of the cost, right, that is going to be something like multiple lakhs of crores of rupees spent on that, right? Just to give you some context, right, the union budget of India this year has a capex budget of 11 lakh crores, right? Imagine a small city, again, Delhi is not a small city, but area wise a small part of the country, you're trying to remove the pollution using these methods, right? So it's like literally putting a air conditioner on a house with no roof, right? It is going to be of zero impact, right? They are never going to clean up the atmosphere to the level that we want, right? The atmosphere runs for multiple kilometers high from the ground, right? And there is diffusion of particles instantaneously, right? And it's sad to know that many of the these proponents of smog towers are from elite education institutes from our country, right? Not to name them personally, but the short form of them starts with an I and ends with a T, right? So it's really sad, the kind of discourse that is happening, right? So the main aim of the paper is to have more data driven discussions, right? So let's directly look at some of the policy discussions, right? So for example, an odd even policy, right? Now in the month of October and November, where we know that most of the pollution, and we have clearly pointed that in the paper as well, right? So most of the pollution that you notice during that time is coming from either side of the Punjab, right, where there's crop burning, right? So like I was telling a joke to my one of the co-authors, is that divided by Radcliffe line, united by stupidity, right? So either side of Punjab there is crop burning, and that leads to this pollution. No amount of odd even policy is going to reduce the pollution, right? It's just a measure to show by the government that we are doing something, right? And I want our governments to do something rather than being seen as doing something, right? If you get the difference, right? However, if you look at the months of December and January, right, when most of the pollution is local, at that time something like an odd even policy, I'm not completely opposed to it, right? The other point that I wanted to make is that if the government has so much money to install these smog towers, and all these are broken window economics, right? You try to actually solve a problem which you can avoid in the first place, right? And also look at the amount of air purifiers that we have to sell, right? And this is a cost on the not just the government in terms of installing these smog towers. The air purifiers actually work, right, because they are operating at a confined space, right? But that burden is on individual homeowners, right? And not everybody can afford these air purifiers, right? So in fact, there is an equity problem also out here, right? So the key point I would like to highlight is that I'm not claiming to have all these answers, right? But what the method in the paper talks about is that you can actually know what are the causes of the pollution. For example, when the electricity demand is very high, and you know that from the particle analysis that the wind is going to come from some of these big heavy thermal power plants in our country, right? Towards Delhi or some urban centers with a very dense population, right? You can actually choose to operate some other thermal power plants in different parts of the country, right? Again, it's easy to say out here when the energy demand is high and we as a country do not have excess capacity of power, right? So I understand that these trade-offs are not always easy, but at least those are some of the data-driven decisions that we can take, right? Just to point out one more factor, right? So most of our power plants, earlier power plants that were built many decades ago, were close to the regions where coal was abundantly available, right? So these are the regions like Vidarbha region, Chhattisgarh, Chota Nagpur, Jharkhand, some part of Bengal, etc. Right? You will notice that most of our old power plants are located there, which happens to be bang in the center of the country, right? So anywhere the wind blows, some people will be affected by this, right? So as we cannot do away with thermal power plants, that's an unfortunate reality of things, right? Maybe can we build these power plants near the coastlines, right? Now again, that may have some other unintended environmental consequences, and I'm not like trained to actually give a good cost benefit analysis, but we should be doing cost benefit analysis of these kind of decisions, right? And do we need to use homegrown coal, right? Can't we use imported coal which is of higher quality and lower sulfur content, right? Now again, a geopolitical person may say that you are compromising our energy security, right? And I will not debate that person, right? I'm just saying that let's do some cost benefit analysis, right? Geopolitical versus human health, right? Operating some thermal power plants during certain times of the day, so that some part of the country which is thickly populated is not getting the sulfates that are released, that are reaching that particular place from these power plants, right? So I'm just saying that let's talk about those trade-offs, right? Rather than some bureaucrat sitting somewhere and passing some judgment without even noticing the complexity of this matter, right? So that is what is actually the most frustrating part of it.
Right, right, and you correctly mentioned that if we have the amount to spend on smoke towers and other such policy interventions, there are other policy interventions which probably would have much more bang for the buck, right? Say, for example,
Right, right.
metros or buses or renewable energy, right? So we were talking about some of these things offline. Maybe if you want to elaborate
Yeah.
on some of these.
Yeah, even though the previous rant of mine was pretty pessimistic, I just wanted to highlight that it's not like these problems are not solved, right? So Los Angeles in the 70s was one of the most polluted cities in the world, right? And that's when they introduced measures on, and they identified the problem, right? The main source of their pollution was vehicular emissions, right? And they made sure that increasingly every vehicle that is sold in the state of California should have like some emission standards or emission norms that have to be followed. Now, no car manufacturer is only going to make cars for just one state, right? But this is a big state, right? It's California, which is like probably 10% of US GDP is just the one state, right? So because of this measure from one state, car manufacturers had to make more and more efficient cars which have lower emissions. That actually had a trickle down effect on other parts of US as well, right? Similarly, why to look inspiration in some other country, right? Even in our country, right? So although it's not mentioned in the paper, in fact, almost it's reported that more than 2 million deaths in India occur because of pollution. And a significant portion of those deaths, in fact, were happening because of indoor pollution, because women and children in our homes had to breathe in air because of, firewood or coal-based measures that were used to stoves that were used to cook food, right? Because of Ujjwala scheme, right? I mean, people may claim that it's a subsidy or whatever be the case, right? Because of the delivery of Ujjwala scheme, literally almost 90 to 95% of the households in our country have now LPG gas, right? So imagine the number of deaths that we have really reduced, right? It's obviously over the past 7-8 years, it has we have saved millions of lives just by this scheme, right? So it's not like hard problems cannot be solved. It can be solved by targeted public policy, right? So similarly, as you pointed out, right? So in case of our urban cities, right? So Delhi happens to have one of the best metro network, in fact, the best metro network in the country. But even then, people prefer to use four-wheelers because the feeder systems into these metro stations are not there, right? If you look at the newspaper reports from 2014 onwards, the number of buses that were running on Delhi has come down by more than 50%, right? So it's okay to have actually diesel buses which pollute a lot, but one diesel bus can actually I can put good money on the fact that one diesel bus will produce much less emissions compared to 50 cars that are driving on the roads, right? So imagine having much more frequent buses, many more buses. And that's a problem in many of our urban centers, right? So our public transport system is abysmal, and it's about time that we have a holistic picture about, not just blaming about some farmers burning their produce after harvest, right? I mean, I'm not saying that we should not be taking action against those kind of actions taken by individuals or farmers, right? I'm not suggesting that for 1 second, but there are many more things that you can do, right? So the crop burning that happens has high pollution levels in Delhi for 1-2 months. What about the other 10 months? What are the other factors that lead to it, right? Similarly, imagine instead of spending money on these smoke towers, etc., can we give subsidies to our industry? For example, can you tell our steel power plants to convert to more electric arc furnaces, right, rather than the traditional blast furnaces, right? So again, this may again be branded as, subsidy to the rich or subsidy to the industries, but imagine the trade-offs that we have, right? We are compromising a few thousand crores for lakhs of crores of health bill that our country is suffering, right? So we are a third world country, a very poor country. So specifically for us, right, we have to make decisions that have very big ROI, right? For the least amount of effort or money, how can we get the maximum outcome, right? So that's the kind of strategic mindset which I feel is missing. And it's not like the problems cannot be solved. We have solved major problems, especially in this current field of pollution itself, right? Which is quite commendable, right? So it's just about the will to have a much more informed citizenry to push the government or the elected representatives, and don't give them some easy way outs, right? So the farmers in the neighboring states are polluting, we cannot do anything about it, right? So we can definitely do many things about it, right? Can we have some schemes to, as we know, right? I mean, I know this is not a discussion about MSPs, etc., right? So we clearly know why there is parallel burning happening in Punjab and other places, right? One, of course, it's because of myth that by burning the actual ground is much more fertile, which is blatantly wrong. Also the fact that because of this MSP support that is given, right, which leads to excessive use of water, excessive use of fertilizers, all these things have a very big negative impact, and then you leads to crop burning, right? What if we can incentivize the farmers near that area to grow more pulses, right? India still imports a lot of pulses, right? And I'm very sure a geopolitical expert will agree with me that we should be food independent, right? And one way to become food independent is to stop buying pulses or oil seeds from rest of the world, right? Why can't we incentivize farmers to do that, which may not lead to the same kind of crop burning events that we happen, right? So we just need to be little bit much more smarter in our decision making.
Right, right. And so basically, what you're saying is there are different ways of tackling it, and instead of having like a one size fits all solution, it's better to look at different factors that affect it. So, for just to give some examples from your paper itself, right? So you've mentioned the impact of sulfates in winter, right? And you've found that like 7 of the top 20 most important locations were probably from Singrauli, which is in Jharkhand, central eastern India, right? And that's Singrauli and its surrounding region have like many thermal power plants and other industries due to this easy access to coal and I guess minerals in that area, right? So
Right, right. So
even though it
just
was
to correct, Singrauli is in UP, but it's at the Tri-Junction area, right, where MP,
right,
UP, and Chhattisgarh, that area, right?
right,
So yeah, so that happens to have one of the densest congregation of thermal power plants in the country, right? So
right,
of course we can take steps to make sure that, yeah, so the actual graph that you are referring to in the paper, and of course we can add the link to the paper in the podcast notes, it talks about the fact that Singrauli, which is almost like 800 900 kilometers away from Delhi, happens to have a very high predictive power in terms of what the sulfate levels are going to be in Delhi during winter months, right? So again, I want to just clarify one more thing, that correlation is not causation. So just because a model is predictable could be primarily because of correlated parameters, right? I For one second I don't want to say that our models work because they are causal, right? But if you look at the second set of graph which you are referring to, it's called what in machine learning parlance called feature importance, right? So we literally use around 700 800 features in our models, and the top 10 contributing features that we get in the winter months when it comes to sulfate happens to be pollution levels in or SO2 levels in Singrauli, some 3 days away, 5 days away, or in the 3 days in the past, 7 days in the past, 5 days in the past, so on and so forth, right? Which literally means that it's not just correlation, but there is some causal relationship between the increased sulfate levels in Delhi and why these features are coming up as the most important ones in our machine learning analysis, right? So again, it's not a pure causal relationship, but as I say, right, if it quacks like a duck, it walks like a duck, it's probably duck, right? So again, I can stick my neck out that there is some causality at least that we have shown in the paper, and that is great from a public policy perspective, right? So you can only solve problem when you know what is causing the problem, right? Like going back to the example of California, right? They identified that vehicular pollution is the main cause, right? And then they designed targeted policy to solve that particular problem, right? Can we do the same when it comes to operating our power plants during different times, or moving them, or making them more efficient, changing the fuel type that goes into them? I mean, again, I'm not a plant expert or thermal power operator, but I'm very sure that government with lakhs of crores of money at their kitty can come up with a better solution. And in fact, it's almost like a Ayushman Bharat scheme, right? So this will indirectly be an insurance policy against all the health hazards that people have, right? Just to stress on the point that according to several studies, India is losing around like air pollution causes 2 million deaths every year, right? That number is COVID, TB, malaria, AIDS combined, more than that. And imagine COVID happening every year, and much more dangerous form of COVID happening every year. Those many amount of people are dying every year, right? So it makes sense to actually invest money to improve the health outcomes of people. That's not a lot to ask from our governments.
right, right. And it's fascinating that different factors can have like different impacts, right? So again, reading from a paper itself, right, you've written about nitrates in winter, right, and you have found like 10 of the top 20 features were from in and around Delhi itself, suggesting that Delhi is responsible for a majority of its own concentration of
Correct, correct.
nitrates.
So, yeah, that is because, as I mentioned earlier, right? So, in peak summer and peak winter is when our electricity demand is very high. Right, the heaters have to run for longer time because water is bit cold. You need to run heaters, space heaters, to provide relief in terms of thermal relief, at least, right, because of the low temperatures that are prevalent during those periods. So I believe what is happening during these periods is that there is not just more use of thermal power plants that leads to increased sulfates. But what is happening is that because of the temperature inversion point that I mentioned earlier, the PBLH, or the planetary boundary layer, which is coming very close to the surface of the Earth, pushing the pollutants down, and also the fact that the amount of blackouts and brownouts that our country sees, right? It would be very wise from the government side to actually spend some thousands of crores in improving our electricity grid, right? We are always very afraid that our grids can be a source of a terrorist act from outside sources, right? Let's invest that money to make our grids more resilient, make sure that there are no blackouts, brownouts. And if there are less number of blackouts, brownouts, right, people's mind will change, right? They will not think about installing a diesel gensets every time you build a house, right? So it's just a given. We all as citizens have agreed to the fact that, in fact, even in Bangalore, right, where we both stay, it's almost given that every big society will have a diesel genset, right? Because our grid and distribution system is so pathetic that there are these blackout events which lead to having local generation units. And these gensets, as I mentioned, are also a source of pollution and very close to the human habitation, right? So the fact that there is in winter most of the top nitrates are caused by local factors is because of the gensets and the vehicular traffic that is there during those times.
Right. So, as you mentioned, so local policies like odd even rule or suspension of construction activities would therefore be really useful in protecting their quality during such periods.
Yes, yes,
Similarly,
not during the time of crop burning events, because that is such a big factor that any amount of odd even is not going to offset the PM 2.5 levels by a lot.
right,
So I don't believe in troubling the people for the sake of it, right? Just to show that you are taking some action, right? When the source is clearly not that, right? But of course, in the winter time, when most of the pollution is local, what we can do is, can we ensure that the electricity is available 24/7, right? And again, this is not rocket science, Arindam, right? So
right,
it's a joke, right? Every time in newspapers we see that whenever there is election in some state, right, that state has very less blackout events, right? Magically our grids become more resilient, right?
right.
So can't we do that during those 2 months is a simple question I'm asking, right? If you can do during election times,
Hmm.
right, the grid suddenly becomes very efficient and much more resilient, right? Can we do that during those 2 months so that we avoid those already purchased gensets in those homes from operating, right? It's not a big ask, right?
Right, right, and I like that such data-driven interventions help us in making like very targeted interventions. Right. Say, for example, you've mentioned Behat, which is in district Saharanpur, Uttar Pradesh, which is 170 kilometers north of Delhi. That has very important feature as far as nitrates in winter are considered in Delhi, right?
Yeah, it
And
was
you
very
found out,
surprising to us as well.
right,
So what we can think about is that it's again an agricultural region which possibly uses diesel gensets to take out groundwater from the ground. Right, again, something like water availability through irrigation. Like we'll
right,
solve this problem of using diesel gensets, right? And if you give 24/7 power to the farmers also, right, that's also a good thing to avoid this kind of use, right? And also, when we investigated further, we found that there are a lot of these paper manufacturing units in that area which could contribute to NOx gases, right? That could be another reason, right? And also another interesting aspect, right? So if you notice the part about secondary organic aerosols, right, which is also another major component of PM 2.5, right? If you look at PM 2.5 components, one of the largest component is actually secondary organic aerosols in terms of percentage of PM 2.5, right? So if you notice, these are formed by organic carbon particulate matter combining with some reactive gases, say ammonia, right? And if you notice this feature importance graph, you will notice that the ammonia levels in Indian part of Punjab and Indian part of the country is causing higher pollution levels, right? Especially in terms of secondary organic aerosol during the pre-sowing season, right? Pre-sowing season is when you use a lot of fertilizers, right? But if you look at the other side of the Punjab, that's in Pakistan, there more like PM organic carbon is what is causing the impact, right? So again, this goes to show about our twisted economic policy, right? In India, we do subsidize fertilizer use very excessively, right? Fertilizers are highly subsidized in our country, which anytime you subsidize something, it is used in excess, right? And that is why this leads to the formation of secondary organic aerosols, which are also pretty harmful, right? So it's quite interesting that even with this minor in our study, we could identify such cases which can directly point to some economic policies which are directly causing these issues, right? So again, there is a fix to all these things, right? Rather than possibly giving subsidies on fertilizers, why don't you just directly give cash to the farmers, right? Let them take the choice of, do they want to buy fertilizer or use it for some other things, or they can just go completely organic, right? Leave the choice to the farmers rather than you muddling in the market, like being a participant in the market and incentivizing them to use excessive like fertilizers, right? And that causes, like, fertilizers essentially release ammonia, and that ammonia gas can combine with organic carbon to form secondary organic aerosols, right? So there are several steps that we can do which can actually reduce this pollution problem significantly.
I really hope our policymakers like look into such data-driven models, such data-driven insights, and because this gives you such fantastic insight into what could be causing the problems in specific areas. You could identify sources and then take like make targeted interventions rather than like such blanket, sometimes nonsensical sounding interventions, like say a smog tower, which might not even work, right? So that's very fascinating about this paper. Now, zooming out from these very targeted interventions, we you mentioned about metros and buses and other forms of energy, probably, but we didn't talk about renewables and nuclear energy. So those are also, I
Correct,
guess,
correct.
some very important interventions that can be made to tackle this problem of air pollution, right?
Right, absolutely right. So, I'm completely aware that we live in an imperfect world, and we have to always come up with trade-offs, right? I'm not a tree hugger. I mean, I don't consider that term as derogatory, anyways, right? I'm not saying that stop building all thermal power plants, right? I'm not saying that at all. But let's take a long-term perspective, right? So, if you look at a grid, right, it's a marvel of the 20th century, right? It's just fascinating that how it works. Like, it's probably the biggest machine that humans have built, right? Electric grid is a real marvel which was built over a century, right? So if you look at energy demand of people, right, so they follow a certain pattern, right? There is seasonality, there is daily seasonality. When early morning you turn on your heaters, there is a lot of energy demand. During the middle of the day, there are big factories that have to use their HVAC systems or heating, ventilation, and air conditioning systems. Again, in the night time, the energy demand may go down because of lower industrial activity, but again, ACs will be turning on in the homes, especially during the summer months. So there is daily seasonality. There is, of course, yearly seasonality to our energy demand, right? So, of course, the energy demand is not constant. Now, something like a thermal power plant is good for not just the base load. When I say base load, I mean the base amount of energy that is required to run our country, right? At any given point in time, we will be using some thousands of gigawatts of power, right? So, nuclear power is excellent for base load, right? If you turn on the nuclear power plant, it can run for multiple decades, right? And it can supply the base load, right? Unfortunately, solar and wind, they are excellent, like very clean sources of energy, and they're renewable, right? but they are intermittent, right? They depend on the weather, when the wind is blowing or when the sun is shining brightly, right? So we can't control that. And fortunately, if you see the latest tenders that are released for all these renewable plants, right, they always talk about something called as round the clock power, right? So they want the renewable like solar and wind power plants to actually also have some kind of stability in their power, right? How they can do it is two ways, right? Have some kind of storage, right? Either you can have a battery storage, or you can have a what is called as a pumped hydro storage. So pumped hydro is nothing but a special kind of a hydro dam which can also consume power, store the energy in terms of potential energy by pumping the water at a higher elevation, right? Whenever there is excessive energy available, pump the water upwards, right, and release it when there is less of these renewable powered sources available, right? So this can mask the intermittency of the renewable power plants, right? And also, if you notice in the last several years, last 4 5 years at least, the amount of tenders that have gone to build these pumped hydro systems in the country has been increasing, which is quite positive, right? After us being in slumber for many years, right, the nuclear power is again making up a comeback in our country, fortunately, right? We have cracked the code when it comes to pressurized heavy water reactors, right? We know how it works. It's operating for decades now. It's quite safe, and we are building more and more of those, right? It's extremely clean form of energy, right? And also, India is blessed with a lot of thorium. Now, again, to use that thorium, we have to go through what is called as a three-phase energy program, where initially you use the nuclear waste from the existing nuclear power plants, then you mix this waste with thorium to give it to what is called as the feeder reactors, and then what is output is a different isotope of uranium which can be used for direct fission and energy generation, right? So that is probably several years away from us, but the existing nuclear power plants, we have good experience of not just operating them but also building them, right? So one way to as I said, right, pollution is a multi-pronged problem. It's multifaceted, and there are several reasons. It's never monocausal, right? So there are several steps that we can do as a country, and which will have other benefits also, like the emission controls of California benefited rest of the country, right? If we actually take some actions of spending money on increasing the bus network in different parts of the city, right, this is going to change the lives of our countrymen, right? So imagine low wage earner investing their money in buying two wheelers, etc., right? And then they have to pay the EMI for multiple years together, right? If there is a reliable, cheap public transport system, it will not only reduce the pollution problem, it will decongest the roads. We can travel faster, and people who can't afford, will be reducing the burden on people to buy vehicles, right? So there are a lot of knock-on second order benefits that will accrue by doing the right things when it comes to maintaining good grids, having proper public transport system, right? And these things are such a good public good that we should do it any which way, right? Forget about the pollution problem in the first place, right? We should be moving towards more nuclear power. We should be moving towards better public transport system. We should be having more of renewable power sources, right? So we just don't need this one pollution problem because of which we need to solve them, right? These happen to be the problems that we are facing as a country, right? So it's just common sense from my perspective to focus on these things to alleviate the problem of air pollution that we see.
Right, fascinating. That's fascinating. Are there like any other such government initiatives, like local initiatives that have worked around the world that come to mind apart from the ones that you've already mentioned?
Yeah, so as I mentioned, right, not just in US, right, in so the whole, so for example, that we have Bharat 1, Bharat 2, Bharat 3, Bharat 6 stages, right? Essentially, all these are like very similar. They're based on from Euro 1, Euro 2 standards that have been established in Europe, right? So if you notice, like many years ago, there was a cap on diesel vehicles that you cannot operate for more than 10 years in the national capital region or Delhi, right? That led to a sudden drop in people buying diesel cars, right? Of course, diesel, if you look at NOx and other pollutants, it is much worse than petrol vehicles. But if you look at the latest diesel vehicles, right, they are highly efficient, right? In fact, in the next stage, in the Euro 7 stage, it will be really low emissions, and it will actually be comparable to petrol vehicles, right? So all these initiatives have helped, right? Please don't get me wrong, right? Imagine us driving Bharat 1 cars at this stage, right? The PM 2.5 level will be much, much, much worse than what we see out here, right? So I'm not saying these things have not worked. We just have to have much more rigor in terms of having a data-based approach, have targeted schemes, right? As I mentioned, right? So India is probably the only country which is going to have more and more steel plants coming in, right? China had a significant steel capacity, but because of their economy slowing down, one of the primary users of steel was in home building in China, which is their real estate sector is really suffering. So the new steel manufacturing units that are going to come up mostly are going to come up in India, which is essentially one of the big drivers of the world economy, right? So can we make sure that we subsidize these industries to go towards much more practices that are better for them, right? For example, subsidizing them to have these electric arc furnaces, right? And again, there are knock-on benefits on them, right? So don't for a second think that European countries will be very happy with our steel being exported there, right? They will put some conditions like you are producing it in a not so green way, so we'll put tariffs on you, right? So some kind of green tariffs, etc. In fact, by doing this kind of electric arc furnaces, we are not only reducing the pollution levels in our country, it's going to help our steel manufacturers to actually sell the steel in more developed markets, and we are going to get a benefit out of that, right? So there are, like as I mentioned, there are second order and third order benefits, which in itself makes sense to make this investment irrespective of the improvement in the pollution levels, right? So there are several things, as I mentioned, right, that we can do to alleviate this problem, and in fact it can be a net good even in terms of economic activity going forward.
Absolutely, absolutely. And I think this paper of yours provides a very important suggestion to the policymakers as to how they should approach these very difficult problems, right? And what could be the steps that should be followed before taking such policy interventions? Maybe look
Correct.
at.
So
Hmm.
yeah, so they can actually do what if analysis, right? So instead of so we have come up with these different sites in the country, right? Let's imagine that tomorrow you want to install a thermal power plant. As I mentioned, I'm not opposed to any thermal plant from coming online, right? Can you do some analysis based on this high split approach that we mentioned, where the molecules are tracked, how the air molecules go around the country? Can you do such analysis to identify what would be the net impact on our countrymen, right? Again, I'm not saying that stop all thermal power plants, right? It's probably not very practical for a growing country like India, which will have continue to have increasing energy demand in the future, right? Can we do some kind of basic data based analysis to identify, is the site right for building this kind of a plant, right? Again, it's a matter of running a few simulations to identify, right? So I'm just saying that rather than arbitrary choices that bureaucrat might make, right? Can we make much more informed decisions? Is my main point.
Right, right. And it would be fascinating if you could, provide a way for policymakers to maybe play around with your pollution mapper model, right?
Right.
Make it open to public, and then
Sure. So
policymakers use it.
actually, Arindam, like the paper is in public domain. And in fact, I'm not using a lot of complex computer science stuff, right? For example, I'm using an open source data set called GeoCF from NASA. We use some other data sets, some from Indian government, right, to identify like which were the locations of power plants, etc. Right. Other than that, we are using the Lagrangian simulation method, which is like a 7-decade-old algorithm, right? Nothing new. The machine learning algorithms that we used are also very old, not nothing new, right? They have been existing for multiple decades, right? I'm not using some fancy AI algorithms out here, right? So anybody who reads the paper can actually do it, but I'll be happy to assist anyone to implement it for their own city, right? Why should we just restrict our analysis to Delhi, right? If you look at the PM 2.5 level, whole of North India, the whole Gangetic belt is suffering from high pollution levels, right? So can they run these models for their own cities to push pressure on their elected representatives to do something about this thing, right? So we any momentum coming from ground up, right, will have a positive impact, right? And at least I'm very hopeful, even though through this discussion I may sound very pessimistic, but I'm actually very hopeful, right? Our democracy works with a lag for sure. There is inordinate lag, which is very frustrating, but it has worked in the past, right? I've mentioned some positive examples in our own country, right? And again, as a world, right, we have solved big problems. So sometimes the alarmism goes in very absurd direction that our world is going to end, etc. Right? We have solved some big problems in the past. For example, the ozone hole, which we had studied in our textbook some 20, 30 years ago, we all at that time thought that the world will come to an end, right? But collectively as a world, we decided that we are going to stop producing chlorofluorocarbons, right? And what we see is that the ozone layer is repairing itself up, right? So it's a major achievement, right? There was talk about increased incidence of skin cancer because of UV rays coming, harming people who are close to the poles, who are going to be more exposed by these ozone holes, right? So we have solved major problems in the world by collective action and much more targeted action, right? It's just about political will to solve it. And for political will to happen, we need our democracy to function. By that I mean not just voting at the time of election, but actually putting pressure on our elected representatives and call the nonsense sometimes which is being spread out, right? Like, for example, we have seen that different parts of the country, there are trucks which spray water on the roads, right? That's not going to reduce pollution levels, right? This smog towers, as we mentioned, right, it's more like a gimmick, right? We want the elected representatives to not just act as if they are doing something, but we want them to take some tough decisions to improve the lives of people.
Right, right. It's been a fantastic discussion, and we have covered quite a bit of ground. Just before we end our podcast, is there something about your paper that you would like to talk about briefly? Provide some more, because it has. I would urge all our listeners to go and read this paper. It has done a fantastic job of analyzing factors and then building this model. I was really fascinated about how you chose the 68 features or sources, right? So, if you could elaborate on that and maybe any other aspect of your
Right.
paper which is interesting, maybe from a technical point of view, maybe from a public policy point of view, right? So, yeah.
Right. So Arindam, I was interested in the pollution problem from a much more technical point of view earlier before this paper. We also have a couple of other paper which talks about efficiency of mobile sensing, right? So essentially what we said is that we in fact collaborated with one of the taxi aggregators in our country to install pollution monitors. And as these, so the problem with static CPCB monitors is that they are at one location, right? So we wanted to explore how we can install sensors on cabs and how we can get much more denser map of pollution readings. Point number one. Another work which where we were helped, we worked with an NGO which funds electric auto rickshaws in Bangalore, where we incentivize driver to go in to take slight detours, right? And while doing that, we actually took the permission of the people who were riding on the auto rickshaws also, right? Are you okay to take a slight detour so that we can collect pollution values in some part of the city which where we are not collecting, right? So it was more like a coverage problem, more of a computer science problem of collecting a very dense so simulate a dense sensor network. Even though we have fewer sensors, the fact that sensors itself are moving, we can get much more wider set of values, right? But what I found while doing that work is that it's all good to measure pollution values, but we need to do something about actually solving the problem, right? Measuring is just one aspect of it, right? So that's when I was interested in looking at different data sets, etc. And fortunately, just because of sheer luck, we found a atmospheric chemist scientist in terms of Pankaj, one of our co-authors, right? He was a PhD student from IIT Kharagpur, currently doing postdoctoral research, right? So he educated us a lot about atmospheric chemistry, how it works. He introduced us to several of the data sets that we could use for our analysis. And essentially, if you see, the paper doesn't have a lot of advanced AI. So all the AI that we used is like very old AI, easy to understand, easy to explain, and easy to replicate, right? So thanks to NASA data, it's now available for all over the world, right? We can run these models for every city in the country, in fact, right? So it has just democratized doing all these simulation work, right? For example, today our laptop probably has more processing power than what US government had some in 1950s, right? So this gives us tremendous power to do a lot more analysis than what they could do. So earlier the high split pollution dispersion model that they had invented 7 decades ago, right? They had to run those simulations primarily during the times when there was a volcanic eruptions to track where these volcanic matter is going to go, right? They could only use for very specific events, right? Now, because of the ubiquitous nature of compute, right, we can actually do this analysis for every big city in our country, every medium sized city in our country as well, right? So what I feel is about this paper is that this has really democratized more data driven discussions, right? Very importantly, we can actually point, again, to repeat my point, correlation is not causation. We have good predictive model doesn't mean we can directly have a causal impact directly shown, right? But the feature importance part of the paper essentially talks about what are the factors that actually affect pollution level at one place, right? There it's a clear smoking gun, right? So for example, we all know that pre-monsoon times there is a lot of southeast wind coming, and which brings a lot of dust from Sindh in Pakistan and Thar Desert in India to Delhi. Right? It's a very well-known fact. We don't need my models to tell you that. But that validated our model, right? If you look at how the progress of dust happens, most of the factors that cause dust in Delhi were shown to be from Sindh and Rajasthan, right? Which was, we were very happy to see that, because that's like a validation of our models, right? If our models works quite well in identifying one particular type of phenomena, which we know definitely is true, right? There is very high likelihood that it is true for other phenomena, right? So again, going back to your 68 points, right? So there is definitely a bias in our work. We are not denying that. We chose that 68 because of the sampling approach that we took in our paper, specifically to focus on Delhi. So we chose locations in the subcontinent which are first closer, second have one of the active sources of pollution that we know, right? Like biomass fires, highlighted by satellite imagery, population density. We know that big cities have a lot of population, and some human activity leads to pollution, like vehicular emissions, running gensets and all, having a manufacturing unit, etc., right? And other factors include like big power plants and steel industry, right? So these things can, I mean, I'm not saying that these are the only 68 regions that cause pollution in the country, but they seem to be highly predictable to the extent that the error that we get at an individual constituent of pollution level, right? We mentioned that there are 7 constituents to PM 2.5, right? The error that we get is around 9 to 20% error, which is not very high, especially when we are talking about hourly pollution values, right? I'm not talking about a daily pollution value. Like simple arithmetic will tell you that if you average for a longer duration, the errors would reduce, right? So we are doing it at an hourly granularity, which gives you a lot more power to run some what if analysis, right? So tomorrow, if I turn off this thermal power plant, I can actually see what will be the sulfate reduction in some other part of the country, right? So these are the kind of possibilities that exist, and I at least enjoyed a lot writing the paper and doing those experiments, and quite a lot of this was quite eye opening. And just wanted to end with one fact that, in fact, if you don't understand any of the technical discussions that happened today, right, which is totally fine, right? I will just recommend you to read a book written by Tim Smedley. He's a journalist who has written the book called Clearing the Air. The evidence that he has mentioned in this paper is like mind blowing, right? So I also suffer from a bit of asthma, so I relate with the air pollution problem. But if you read that book, I'll highly recommend that book that your listeners read about it. It's crystal clear, right, how this pollution problem has gone out of control, right, and how several countries have actually taken some decisions to solve this particular problem as well. So yeah, I would like to end with that. And thanks a lot for this opportunity, right? It was great fun talking to you.
Right, right. We usually link this book also in the show notes. And yeah, as you said, I have also learned a lot from reading a paper and this discussion. And the most fascinating part was about the public policy angle, where we could use such models to actually make very targeted, informed, data-backed decisions, right? Decisions that are not just a coin toss, but would have some probability of actually making an impact on the ground. So yeah, thanks for this wonderful discussion here, and I'm sure our listeners also loved it.
Yeah, great. Thanks a lot. Thank you.
Thanks a lot, Srinivasan. Thank you. To our listeners, I hope you enjoyed this discussion, and stay tuned for our next episode. Thank you. Bye.
If you liked our show, dive into Takshashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle @TakshashilaInst or our website takshashila.org.in.